So we should be teaching questioning skills. Isidore Rabi, who became the nuclear physicist, who got the Nobel Prize in the 1944, whenever he used to return home, his mother will ask that, boy, have you asked a good question today? And asking question, that is development of scientific temper, is not only the monopoly of the scientists. Like if you have been to Shantiniketan, the main museum, Rabindra Bhavan, it has an annexe library. And these days, all the books which were read by Gurudev Rabindranath Tagore are being digitized. It really gives me shivers to my spines. I had picked up one book written by a famous science teacher, Charuchandra Bhattacharya, a book which was read by Tagore, and Tagore had not spared any page. At every page he has given his comments. An adolescent Tagore writing his comments. Now, there was a chapter on electromagnet, and Tagore has written in Bangla, খুব জটিল বিষয় না দেখলে বোঝার উপায় নেই. It's a complicated matter. I can't believe it unless I see it. So this is scientific temper. I can't believe it, and that had got vividly revealed through several writings. If you read Vishwa Parichaya, through several writings of Tagore. So we have to train the art of asking questions. I'm not talking about any religious belief, but when Swami Vivekananda, he was going for his quest for God and going to several sages, well, he asked a very direct question, have you seen God? And in most of the cases, he went even to Maharshi Devendranath Tagore, father of Gurudev Rabindranath Tagore, and he got the answer in negative. But he gets the answer in affirmative from Ramakrishna Paramahansa at Belur Math. And then Pat comes the next question, can you show me? So see the directness of the question. So we have to teach questioning skills rather than answering skills to drive home innovation and discovery. And then how are we handling the labs? See, there is a exercise book called Laboratory Notebook. All of us have seen that. Now, again, from the point of view of the English grammar teacher, the word laboratory is the adjective of notebook, which means that, which qualifies the notebook as an exercise book to be used in the laboratory. How many times we use it in the laboratory? Even the teachers, they tell the students that that has to be kept very neat and tidy. Okay, it should not be made untidy. But what the student is doing, he is taking the readings in a rough notebook, going back home and copying the result from the rough notebook to the fair notebook. So the laboratory notebook is not being used in the laboratory. And I'm quoting what a famous professor of physics, G.L. Square, has said. He says, down with copying, firstly because it is an exercise in wastage of time. Number two, while copying, there can be mistake. And number three, which is so crucially important, well, there will be an irresistible temptation of being selective. I know that these are the points which should fall on a straight line, and I have observed some of the points which are not falling on the straight line, so I'll remove those points from my data. So see what I'm doing. I'm doing scientific dishonesty. I have taken an observation with my own senses, with my own 5 organs, and I am ignoring that data which I have observed. What's the harm in keeping that data and trying to analyze what has gone wrong or to interpret that data? Otherwise, how science will roll on, how science will develop. So please try to inculcate in the mind of the student that the laboratory notebook should be used in the laboratory. Coming to the issue of evaluation, again a real life incident. At that time, I was taking practical classes of the higher secondary students, class 12 students. And in the laboratory class, you know, you are not only one. So you had a partner teacher, and my partner was a very senior partner. And then somebody came out with the data. He was asked to obtain the specific gravity of copper sulfate solution. Specific gravity copper sulfate solution is around about 1.09, 1.1, something like that. He obtained the specific gravity of copper sulfate solution is 31. So my senior partner, now normally what we do, we see the result and we just write repeat if it does not agree with the given value, the accepted value. So he didn't even bother to see the script. He said that you have made a discovery, you go back and try again. He scolded the boy. But the boy was very particular. He said that, sir, please find out what is my mistake. So then, since he he was insisting. I requested my senior partner, I asked him, sir, please allow me to go through whatever he has done. You know, in evaluating specific gravity, there is a temperature correction. And measure specific gravity into density of water at T degree centigrade. And density of water at T degree centigrade, the symbol is rho, T comes at the suffix. And density of water, you know, is nearly 1 gram per cc. So whatever observed value you get, if you multiply that by 1, it would be almost that. That is, if you have got x, then it would be x into 1 equal to x. Now, unfortunately, the book that the boy was following had a typo. This T was not a suffix, it landed exactly beside rho, and it appeared rho into T. Now, he was not a good student. He should have observed, he should have made an introspection that he knows the specific gravity of Mercury is 13.6. So this is about 2.5 times heavier than Mercury. So he should have felt that, which it was definitely not. And then, if you multiply with temperature, then specific gravity is a dimensionless quantity, but it gets into the dimension of temperature. So he was not a good student, but I can't help respect his honesty. See, room temperature was about 30 degrees centigrade. The value of specific gravity was 1.09. Multiply 1.09 with 30, it comes to be about 31. It was due to a typo in the book he was following. T, rather than becoming suffix, it came after rho, just on the right-hand side. And so it BSc nursing program, whenever we wanted to introduce that, and particularly in West Bengal, the first reaction is Havena. It cannot happen. The director health services told me that I'm not going to take injection from a nursing student of IGNOU because how can you teach pushing injections distance mode? Anyway, I explained him the entire gamut of experiments, and one such experiment was with applied sciences, and in applied sciences, all 4 disciplines were there: physics, chemistry, zoology, botany. And in the physics lab, they had an experiment called verification of parallelogram law of forces. You know, IGNOU does not have its own infrastructure. We have to go to places to beg for infrastructure. Of course, we go with a golden bowl. We say that we'll pay this much money for the laboratory, we pay this much money to the faculty. So in that laboratory, they could set up all experiments except for that which is needed to verify the parallelogram law of forces. The experimental setup was nothing, 3 pulleys, and the weight had to be hung. So what we did with one of my friends in that particular college, we took corks of bottles and we used threads, and almost in no time, in 10 minutes or so, we could set up the arrangement. So I was about 25, 26 younger at that time, and naturally feeling very elated. That, see, what a great thing I have done. They said that they could not set up the experiment, and in no time I have been able to set up the experiment. So I was basking in that glory. And in the meantime, I heard the students of nursing whispering at my back. They are non-science students. They said that, see, this particular arrangement is used for giving traction to an orthopedic patient. This particular arrangement is used for giving traction to an orthopedic patient. Believe me, I never felt so ashamed in life. I know the theory of parallelogram law of forces. I can set up the experiment, but I don't know the application, which these girls who have not studied science, they know. So the crucial feature is about real-life applications. Whenever you teach a theory, please tell about the real-life application so that they feel science, and then only they will be able to apply innovation. 2 more examples, sir. One is the proof of binomial theorem. Now, see, I really get appalled when we see the derivation being done using the method of induction and big formulas, NCR plus NCR minus 1 is equal to n plus 1 CR. But do we ever tell the students how Newton did the calculation, how Newton arrived at the binomial theorem? I think we have never told. And see, I'll try to explain it orally. I purposely am not going to use PowerPoint or any chalk and talk. Now, say A plus B into C plus D, all small, remembering Professor Roy's example. A plus B into C plus D, you get a 4-number expression, AC plus AD plus BC plus BD. And in all the term, there is contribution from the first bracket, there is contribution from the second bracket. It's a 2-degree term, and 2-degree term is not appearing from contribution from a single bracket. Say the term AC. So A comes from the first bracket, C comes from the second bracket. A comes from the first bracket, D comes from the second bracket. So if you have A plus X into A plus X n times, I'm talking as a mathematician, so it is n times. Then there are n brackets, and this would be an n degree term. And each term will have contribution from every bracket. So in the first case, all brackets will contribute A, and that would be A to the power of n. And how many such terms would be there? You are taking n A's from n A's, or you are taking 0 number of x's from nx, nc0. So the coefficient of A to the power of n is 1. What would be the next term? N minus 1 brackets contributing A, and 1 bracket contributing x, A to the power of n minus 1 into x. So 1x from n x's, the coefficient will be nc1. Then the next term would be A to the power of n minus 2 x square. So 2 brackets contributing x, and then remaining n minus 2 bracket contributing A. So 2 x's from n x's, the coefficient will be nc2, and that's binomial theorem. The general term would be ncr A to the power of n minus r x to the power of r. So we should teach direct approaches, and particularly we should make the students feel the excitement of understanding the subject. One last example, and this is not from the area of science, but it has created tremendous impact when I got to know about this. An excellent teacher of management, was an excellent communicator, was taking a lesson in management. It was an excellent class, but in that particular class, there was a visually impaired student. And while doing so, he had to make reference to the normal distribution. Now, the visually impaired student was also extremely brilliant. I should not say also. In fact, a visually impaired student can be brilliant. So he asked the teacher that you explained using the example of normal distribution, but I could not get what is a normal distribution. Naturally, how a visually impaired student can know about normal distribution. The teacher initially was very much taken aback but he being an excellent teacher, he wanted to tell how a normal distribution looks like. Now that was winter month, and he was having his comforter, which is longer than my handkerchief. So what he did, it is much longer than the handkerchief. So you have to visualize this as that scarf or the stole which was given to Srikant yesterday. He put it on his head, and that stole came up to the shoulder. And he walked up to the student, to the visually impaired student, and asked him to feel the position of the scarf. And he understood what is normal distribution. A great innovation. So this is how a teacher has to innovate. He has to depend on the things which he sees around him, and he should not complain about infrastructure, and he should develop questioning skills. Saying so much about mathematics, which is a very favorite subject of mine, I'll finally ask you to be very, very non-mathematical. See, mathematics in one respect. Mathematics says that if you take 2 out of 5, 3 remains. The lesson of subtraction. But if you give compassion, confidence to the student, it grows in yourself. So be non-mathematical in giving compassion and inculcating confidence in your learner. Thank you very much for giving me patient hearing.